Good morning, Prof. My name is Pony. Together with me, I have Jennifer, Jasper, Nofal, Sam, and Wesley. Today, we'll be sharing with you on our IoT group project. So this will be the outline of our presentation, starting with the background and the problem statement, followed by the proposed solution, individual components, key innovations, challenges, and finally, the conclusion. So let's start with some background to give context to the problem. Pet owners often find their kitchen bins being tampered by their pets, especially dogs. Such behavior may lead to health issues and create an unhygienic environment for the household. Dogs may ingest dangerous substances such as chicken bone shards or packaging materials. Therefore, the following are some of the consequences that arise from the scenario discussed previously. Dogs can ingest toxic food items like chocolate. They can choke from plastic bags. They can also be injured by sharp objects such as glass shards or syringes. In some extreme cases, it can also lead to pancreatitis, which is a condition that causes their pancreas to be inflamed. To put this in better perspective, we can refer to a study conducted by the Department of Health and Animal Science by University of Milan. The study here shows the outcome of grape intakes in a range of doses across various dog breeds. So, if you were to look at Golden and Labrador Retrievers, as they are one of the most common breeds in Singapore, consuming anywhere between 2.8 to 36.4 grams of grapes per kilogram can cause about 20 out of 43 dogs to die or put to sleep. With that, we have the problem statement as follows. Dogs having a habit of rummaging through household trash bins can lead to health risk and unhygienic living conditions. Therefore, a need to deter these pets from opening trash bin lids arises, ensuring their well-being and maintaining household cleanliness.
Hi, my name is Wesley and I will be talking about the proposed solution. The pet-proof bin is a smart and innovative solution designed to deter pets from opening trash bin lids, ensuring their well-being and maintaining household cleanliness. Our pet-proof bin is equipped with a sensor system including a touch sensor, button switch, buzzer, and LED indicators to detect and respond to pet interference in real time. Additionally, a built-in mechanism is incorporated to deter pets from accessing the bin contents. The pet-proof bin utilizes a sensor system including a touch sensor and button switch, along with actuators such as a servo motor, LED indicators, buzzer, and LCD screen. These components work together to detect pet interference and trigger deterrent measures. The flow of events begins with monitoring the lid status using the button switch. If the lid is open, the touch sensor checks for user interaction. If no interaction is detected, indicating pet interference, the servo motor activates to deter pets, while the LED indicators and buzzer provide alerts. The LCD screen updates the status, and data is stored in cloud storage for reference.
I'm Jasper and I'll be talking about the wiring of the individual components. There are 3 wires displayed in these components, with red connected to VCC, brown to ground, and yellow being the signal. For the touch sensor, the signal wire is connected to digital pin 2, and as for the servo motor, it is connected to digital pin 5. For the LED component in this case, a blue LED is chosen, with the anode connecting to ground, while the cathode is connected to digital pin 3. The button switch has its signal wire connected to digital pin 2, with its other wires connecting to VCC and ground respectively. The LED, which displays the system status, has its serial data line connected to digital pin 11, while its serial clock line is connected to digital pin 12. The buzzer, on the other hand, has its signal wire connected to digital pin 5. This is how the IoT system communicates. The button switch and touch sensor, which acts as a publisher, will send a message to the MQTT broker, ThinkSpeak, before the messages will get sent to the 4 subscribers, as known as the servo motor, LED, LCD, and the buzzer respectively. Data from the publishers will be displayed on ThinkSpeak in graph form, updating fields 1 and 2 for the touch sensor and the button switch. Each MKR bots will be connected to ThinkSpeak through the MQTT client ID, where they have their unique ID and passwords for authentication and will update the same channel.
Hi, I'm Nofal, and I will be sharing with you on the first 4 components that our team has used for the IoT project. In our case, the touch sensor, which is placed on the foot pedal of the dustbin, reads the user input. There are 2 states that will be displayed by the system. When the pedal is not pressed by the homeowner, a green LED light is emitted, implying that the lid is not open, therefore suggesting that the system is in normal state. When the homeowner presses the foot pedal, the red LED light is emitted and the dustbin lid is opened. The data received from the touch sensor is then transmitted to ThinkSpeak field 1. The button switch, which is placed on the underside of the lid of the dustbin, reads the user input. There are 2 states that will be displayed by the system. When the pedal is not pressed by the homeowner and the lid is open, a green LED light is emitted, therefore suggesting that the system is in normal state. When the homeowner presses the foot pedal, a red LED light is emitted and the dustbin lid is open. When the homeowner does not press the touch sensor on the foot pedal but the lid is opened by the pad, the system is not in normal state, hence the LCD screen displays pad detected as well as the LED lighting up. The data received from the button switch is then transmitted to ThinkSpeak Field 1. The LCD screen, which is placed on the front of the dustbin, displays the two states that the system is currently in. When the system is in normal state, the button and the touch sensor is not pressed and the LCD screen displays anti-pad bin coupled with the green LED light emitted. When the system detects that the lid is open without the touch sensor being activated by the homeowner, the LCD screen displays pad detected and is coupled with the red LED light emitted. The LED bulb, which is placed on the front of the dustbin as well, displays the two states that the system is currently in. When the system is in normal state, the button and the sensor is not pressed and the LED on the dustbin does not light up. When the system detects that the lid is open without the touch sensor being activated by the homeowner, the LED light lights up.
My name is Samuel, and I'll be talking about the buzzer, the servo motor, and the key innovations. For the buzzer, it takes its input from the touch sensor and button from ThinkSpeak. When the lid is closed, the buzzer RGB indicator is green, indicating the lid is not open. When the lid is opened but the pedal is pressed, the RGB indicator is also green. When the lid is open and the pedal is not pressed, the buzzer RGB indicator changes to red, indicating an open lid by a pad. For the servo motor, it takes its input from the touch sensor and button from ThinkSpeak. When the lid is closed, the servo motor RGB indicator is green, indicating the lid is not open. When the lid is opened but the pedal is pressed, the RGB indicator is also green. When the lid is open and the pedal is not pressed, the servo motor RGB indicator changes to red, indicating an open lid by a pad. Moving on, I will be talking about the key innovations for our project. A key innovation of the anti-pad bin is the 24 hours monitoring that is active even at night when the user is not around or even when the user is not at home. Next, the product is hands-free and does not require any user intervention. This can be seen from our servo motor and the buzzer, which scares away the pad without the user needing to bring the pad away himself. It is also safe for pets as it is only a visual and audio warning to ward away the pets. And lastly, it is the first in the market to incorporate this amount of visual and audio alerts into the system.
Thank you, Samuel. So while we would consider the result of this project to be a success, it wasn't without its challenges. For one, the sequence of events required meticulous coordination and the conditions for the intended and optimal performance needed to be considered for coherence and seamless operation. Following up on that, once we managed to determine the flow of events, we then needed to integrate it in our code and then into the hardware. So we needed to ensure that the intended actions were reflected and executed, and that the operation between the hardware and software is proper. Then we also faced some issues more on the physical side, which were the connections. We either encountered incorrect wiring or false signals. Lastly, the ThinkSpeak refresh rate also posed timing constraints such as delays, which was related to the type of communication that we would use, so either MQTT or REST API. So we needed to account for the real-time monitoring and responsiveness, and to achieve that, we needed to select the most suitable communication protocol. Looking ahead, we have some plans to develop our innovation further. So firstly, we would like to integrate our system with a mobile application to allow users to monitor and control the system remotely. Next, we would like to utilize more complex sensors and possibly AI for a more enhanced system and in its capabilities. Lastly, we would like for our system to be compatible and integrated with existing IoT solutions or smart home ecosystems for a more comprehensive and well-rounded system. Ultimately, our smart pet-proof dustbin not only addresses the practical issue of waste management as well as pet health and safety, but it also is a step towards a more connected and intelligent home environment, and with further innovation and refinement, the potential impact of our IoT solution would be beneficial in enhancing convenience, efficiency, and sustainability in everyday living. So with that, we have concluded our presentation. Thank you, Professor.